Now we're going to get to use some of the skills we've learned involving exponential and logarithmic equations. And we're going to start with equations that are in exponential form. If I look at these two equations, the one thing they have in common is that the variable, the unknown letter, is in the exponent. It's buried in the exponent, which makes it really hard to solve these until you change them to another form. I would have to guess 4 to 2 times what minus 3 equals 36, and that would not be much fun to guess that answer. Likewise here, there's just too much going on to try and guess 4 times 8 to what power equals 309. But what we can do is we can change the form of these equations. We can change them to logarithmic form, and when we find out where the variable is, you'll see it's much easier to solve these. So before you start a problem like this, you should always label. In exponential form, this is my base. The 2x minus 3, all of that is my exp, exponent. And 36 is my answer. Label, label, label. It will make these problems easier. So what I want to do now is I want to change it to logarithmic form. Alright, so log base b. So log of my base is 4. Log base 4 of my answer, 36. My answer goes next in the parentheses. Equals all of my exponent, this whole thing. Exponent goes across. So my exponent is 2x minus 3. Now it still looks really complicated, but actually it's not. Because this is some number, and I can find out what number it is using the base change formula. And then I'll just have a linear equation to solve. So we do have another step here first before we can begin solving, and that is use my base change formula because we can't evaluate log base 4 in our calculator. So let's do that next. Let's see, this is my B, this is my A, so it's going to be log of 36 on top divided by log of, oops, sorry, you can't see that, log of 36 on top divided by log of 4 on the bottom. Now that's the left side of my equation rewritten in base change formula. Let's bring the other side with, just to keep it from getting away from us. Alright, now I can evaluate the left side. That is some number. Let's find out what number it is. Log of 36, press your log key, 36 divided by log of 4, and I find out it's about 2.58, let's round it to here, 2.585. So 2.585 is now the left side of my equation, because that's what all that equals 2x minus 3. Now look at this. You've solved equations like this before. It's just that we have kind of a messy number over here. When we know we need to get x alone, it's just a linear equation. So we undo anything added or subtracted to the x term first. So I want to add 3 to both sides. Add 3 to both sides. And I get 2x, because the 3's are gone, equals, let's see, that'll be 5.585. 5.585. Alright, so added 3 to both sides. I'm just going to add 3 to that last answer in my calculator, because that's what I just did. Alright, now I'm going to divide both sides by 2. So 5.85, and it's already in my calculator. I just kind of leave those last answers in my calculator so I don't have to round. And I get about 2.792. So I'm going to go over here because I've kind of run out of room. X equals 2.792. So let's review those steps again. We had a problem in exponential form where the variable is in the exponent. Can't solve it. What do? I change it to logarithmic form. I use my little index card to change from one form to the other. Once I have it in log form, I can't solve it yet because it's log base 4. So now I use my base change formula to get them both into log 10. I get an answer. I set it equal to the other side of the equation. I keep bringing this side down. And I begin undoing this linear equation just like we solve equations all the time. Add 3 to both sides, divide by 2, and I get my final answer. Alright, let's try another one. 4 times 8 to the x plus 1 equals 309. Now, this one has an extra step, and here's the reason. In this problem, my base number was alone. I didn't have anything else going on other than raising that base to some exponent. But here, my base number 8 is getting multiplied by 4. I'm going to want to undo that first. I want to get my base alone. So what I'm going to do is I'm going to divide both sides of this equation by 4. I'm going to undo multiplying 4 by my base. What I do to one side, I do to the other side. So on this side, this gets my base alone. And you can't change to another form until your base is alone. I'm going to grab my calculator and find out what 309 divided by 4 is. Oops. 309 divided by 4 is exactly 77.25. Okay, so again, when solving these equations, make sure you get your base alone first. Okay, now I can change this to logarithmic form. So let's get everybody labeled. That's my base, that's my exponent, the whole thing, x plus 1, and that's my answer. So what do? It's log base 8 of 77.25 equals my exponent, x plus 1. Okay, can't solve log base 8, so now we got to change bases. So now I get my change of base card. This is B, this is A. So I'll have log of 77.25 on top, divided by log of 8 on the bottom, equals, bring down the other side of your equation, x plus 1. Now this is a number that we can evaluate, so grab your calculator. Log of 77.25 divided by log of, oopsie, gotta use my log key. Let's try that again. Log of 8. And I get 2.090. Now just leave that in your calculator, don't clear it. 2.090 equals x plus 1. Alright? Now, we need to get x by itself. What do we undo? We need to undo plus 1 with subtract 1. Now I still have that number in my calculator, the 2.090, so I can subtract 1 while it's still in my calculator and write down approximately what I get. 1.090 equals, and on the other side I've got x alone. I'm done with this one. There are no more steps. So we have just solved this equation for what value of x plus 1 when you raise 8 to that power, then times by 4 gives you 309. You can always plug these answers back into the original equation and compute it with your calculator to see if you get approximately this answer.